Okay, let's start by looking at practice problem 1 from on page 207. So in this problem we have a truck that climbs a hill and it's changing its speed from 20 miles per hour to 50 miles per hour, and it's along a straight section. All right, now it's on an incline, and the incline is 8 degrees with respect to the horizon. So if we look at this, and we're looking to find the total work, if we look at this, we're going to have two different types of work being done. One is it's climbing, so it's increasing in elevation, so we have gravitational work. And the second part here is that um, we have acceleration work, right? Because we're accelerating. We're at an initial velocity, and then we're changing to a second velocity, which is faster. Okay? So there's two parts to the problem. Okay. So if we just go through and start to think about, the different parts. So first thing is what we're looking for is the total work. And we're going to start out with mass. Now, one of the things you're going to notice about this particular problem is that when we look at it, we're given information in SI units, and we're also given information in USCS units. Okay, so we have some choices here in how we want to proceed. And the way I chose to proceed was convert what my mass into USCS units, and then use those USC units, do all the calculations, and then at the end convert over to SI units. Okay. So the first part here is just I'm giving velocity. So this is what's given, and all I did was convert it from miles per hour to feet per second. Okay, those are the standard units we're going to use because in the end we're going to come up with units of feet pounds. Okay, or foot pounds. So I change this over to slug, and then I change these over. I go through the conversions, um, you know, feet to miles and hours to seconds. I could go through those conversions, then I come up with the velocities, the two velocities in feet per second. Okay. The next thing I have is I'm just putting down the angle relative to the horizon, and also the horizontal. Also, the distance, the total distance. Okay, because I need that to figure out how much elevation the truck has uh, increased through its travel. Okay, so what you'll recognize here, I have a 8-degree angle. Here I did the diagram, and here's the initial position, then the final position, and I was looking to solve for z. So now I solve for z. It's just going to be whatever length of this of the if you want to think about it in terms of like the hypotenuse, and this is like the opposite side, and it's just the sine of the angle times 1600 feet gives us 223 feet. Okay. Now, governing equation, in this case, it's just the total work is going to be gravitational work and work of acceleration. So here's gravitational work, and here's acceleration work. Okay. The next step is to just substitute in. Here's the gravitational work, and of course now you cancel out um, this in terms of its work. It's foot pounds. This is pounds, right? Slug foot per second squared is a pound times feet, and there's our distance that we've traveled. So here's our force, and here's our distance. Okay, so we come up with 1.23 times 10 to the 6 feet pounds. The next one is the acceleration work, and by definition, it's 1/2 times the mass here times the difference between the squares of each of the velocities, right? The initial velocity and the final velocity. When you go through and perform the calculation, it comes up to 3.86 times 10 to the 5th foot-pounds. Now I add the gravitational work and the acceleration work. I add those two together. I come up with 1.62 times 10 to the 6 feet-pounds. I go through the conversion from joules to feet pounds, and then I come up with 2.2. And I guess I could put a zero here too. I didn't put that, but I could put a zero here for three significant figures, megajoules. Okay? And that is the end of that one.